Hello everyone, today I'm going to teach you how to graph a rational function. The steps of graphing a rational function. First is to find a vertical asymptote. Second is to find the horizontal asymptote. Third is to find the y-intercept and the x-intercept. And 5, make a t-chart. So choose x values on either side and between all vertical asymptotes. Then graph the asymptotes. For example, we have f of x is equal to x plus 4 over x minus 4. In getting the vertical asymptotes, first we need to focus on the denominator of the given. So, we need to equal it into 0. So, x minus 4 is equal to 0. So, transpose the 4, so it will become x is equal to 0. So, that is the answer. Getting the horizontal asymptotes, we need to focus on the numerator and the denominator of the first term. In getting the horizontal asymptotes, we need to focus on the numerator and the denominator. There are 3 rules in getting the horizontal asymptotes. First, if the degree of q of x is less than the degree of q of x, then the horizontal asymptotes will be 0. Second, if the p of x is equal to the degree of q of x, then the horizontal asymptotes is equal to 1. Third, if the p of x is greater than the degree of q of x, then your horizontal asymptotes will be 9. So, x plus 4 over x minus 4. Focus on the numerator and the denominator. The factor of x and y should be equal. Since it is equal, then the answer will be 1. So, your horizontal asymptote is 1. So, let's move in the y-intercept. In getting the y-intercept, transpose the x into 0. So, f of 0 plus 4 over 0 minus 4. Divide positive 4 to the negative 4. So the answer will become negative 1. So that is your y-intercept. In getting the x-intercept, based on the given of the vertical asymptote, transpose the positive 4, so that would be negative 4. Next, transpose, so x is equal to negative 4. In making a t-chart, you should get the 2 values that are less than negative 4 and greater than negative 4 again. So, for example, is negative 4, negative 2, 5, and 6. So, we need to substitute the value of x to the given x plus 4. So, the answer will be 0, negative 0.33, 9, and 5. So, to make a graph, you should plot your horizontal asymptotes and vertical asymptotes. So your vertical asymptotes is positive 4. So this will be. Let us count to up to 4. 1, 2, 3, and 4. So this will be. And your horizontal asymptote is positive 1. After that, you need to plot, plot the numbers on your t-chart. So, negative 4 is your x and y is the 0. 1, 2, 3, 4, negative 4, 0. negative 2 and negative 0.33. Negative 2. So, let us point. Like positive 5 and positive 9. So 1, 2, 3, 4, 5. And to positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here. Positive 6 and positive 5. 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5. Here. And point here. That's how you make irrational functions.
2 hours later.
Hi, I'm Tatiana Cardenas and I'm here to show you how to solve rational inequalities. Inequalities. Solution set of a rational inequality is the set of values that satisfy the inequality. The common method used in getting the solution set is by using the interval method sets. There are 3 steps in solving the rational inequalities. First, set inequality to 0. Find x-intercept by getting the numerator to 0. Determine and define values by setting the denominator to 0. And last, make critical values on number line. Check intervals for the final solution. So for example, we have 2x plus 4 over x minus 7 is greater than 0. So, based on the first step, we need to set this aside into 0. Based on the given steps, first, we need to set the equality to 0. So, 2x plus 4 over x minus 7 is equal to 0. So next is we need to bring them in one line. So 2x plus 4 is equal to 0 and x minus 7 is equal to 0. So now we need to transpose it to the right. So 2x is equal to negative 4. To cancel the value of x, we need to divide both sides by 2. So the answer will be x equal to negative 2. Here, for the denominator, we are just going to transpose the negative 7, so it will be positive. So x equal to 7, because this value is already undefined. So now, we're going to make a number line so that we can make critical values on it. So here, when you are making a number line, choose a number on the right side of the positive and the left side on the negative side. So on the right side, we're going to plot 8. In here, on the negative side, we're going to use negative 3. So now, for this, we are going to substitute the value to x. So now, first we're going to do is to substitute the negative 3. So 2 times negative 3 plus 4 over negative 3 minus 7. So in here, we make sure that the value of x is greater than 0. So in here, the answer will be negative 6 plus 4 over 10. Same goes through 8. So 2 times 8 plus 4 over 8 minus 7. So it means that the number that we chose is greater than 0. So what if we use the value of 0? So 2 times 0 plus 4 over 0 minus 7. So 0 is 4 over negative 7. So that would be 4 negative 7. In this case, we cannot define this as greater than 0 because the denominator is less than 0. So in the solution set, we are going to base our answers on the intervals in the number line. So it means that x is less than negative 2 or x is greater than 7. So how are we going to use the brackets? So in here, we use parentheses because the symbol that we use is greater than and less than. So in here, it will be negative infinite going to negative 2. And for the other side, we're going to put 7 going to positive infinite. So that's how we get the rational inequalities.
Solve and graph inverse function. Before we begin, what is an inverse function? An inverse function, for simple understanding, is just switching the numbers of x and y. This means that the domain of the inverse relation is the range of the original relation, and that the range of the inverse relation is the domain of the original relation. Okay, and this is given for an inverse function. To how to solve it. This given was not a inverse function, it was just a function. So before we turn into inverse function, we have to solve this given. F of x equals x cubed. And we are gonna provide a x-intercepts. We got -2, -1, 0, 1, and 2. These are the given x-intercepts. These numbers can be given by your teacher or yourself. Okay, now we're gonna solve this function. F of x equals x cubed. Since our first x-intercept was -2, okay, then turn x into -2 because that's our x, and this is a cube. Then -2 to the power of 3, so it turns out it to be -8, and the other one was -1, so that means f of -1 equals x cubed. Then of course x will turn into -1, then cube because of this one, of this raised to power of 3. Then it turns out to be -1. Then do it the rest of this given. Just repeat it, then you'll get your answers. Okay, since you solve each x-intercepts into their y's, so we're gonna make a t-chart. Then just copy these 5 different x-intercepts: -2, -1, 0, 1, and 2. Then your y is -8, -1, 0, 1, and 8. Now we're here to transform this t-chart into an inverse function, which means we're gonna make another t-chart for our inverse function, x and y. Then the y-intercepts of the original function, which is this one from here to here. So -8 from y to x, -1 from y to x again, then repeat this process. And here for the y, from x to y, -2, -1, 0, 1, and 2. Well, it looks easy, right? It's very easy. It's simple. Then we're gonna make a Cartesian plane. Then we're gonna plot these points. First, we're gonna plot the points of the original function. We got -2 of x, 1 and 2, then -8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, we're gonna put this. Okay, then -1 of x, then -1 of y. So -1, then -1 over here. Oops, sorry, I forgot to plot this too. Okay, then put the 0 as usual, 0 and 0. Then 1 to 1. Then 2, 1 and 2. Then 8, 1, 2, 3, 4, 5, 6, 7, 8. We're gonna plot it here, just extend that thing, then put 8 right here. Then we're here to graph the original function. Graph that here to there. Okay, that's the graph of the original function. Now we're gonna plot the points, the inverse function. First, -8. Just imagine it, it's right here, -8. We're running out of space. So negative 8 and negative 2 of y. Negative 2. Pop it right here. Negative 1 of x, then negative 1 of y. Negative 1, negative 1. Pop it right here. Then 0 to 0. Still the same as the original one. Then 1 to 1. Then 8 of x, then 2 of y. 1, 2, 3, 4, 5, 6, 7, 8. Just imagine it. 8. Then 2 of y. 1 and 2. Then we're gonna graph our inverse function. Right here. Okay. We graph both of our functions, and as you can see, it looks identical, like a mirror, which is correct because it has to be like that. And to show where the center is, it's right here. Let's place it with broken lines. And that's how you solve and graph inverse function.
Hi, my name is Jana Luisa Monquiton, and today I will be discussing about exponential functions. Okay, first you must make sure that the base is the same, and then after that you would proceed next to the exponents. 2x minus 5 is equal to x plus 3. So then you would transpose the like terms. 2x minus x is equal to 3 plus 5. 2x minus x is x, equal to 3 plus 5 is 8. So that's how you would get the x of the exponent. The next part of my topic will be vertical translation, wherein the solution is b raised to x plus or minus c, wherein c is the constant. We've set the values of x into 0, 1, and 2. So to solve the values for y, we must substitute x with the first value of x, which is 2 raised to 0. And when we would disregard the plus 2, and as we go on, we would get the value of 1 and then this. Now let's move on to solving this group of points. First, let's substitute x with 0. 2 raised to 0 is 1, plus 2 is equal to 3. Stop. Now let's proceed to plotting the points. Let's first plot x and y. So x is 0 and the y is 1. Paano ito makikita? Next is 1. The x is 1 and the y is 2. Next is 2. The x is 2 and the y is 4. Now, we will move on to plotting the x and the 2x raised to 2. So first, 0 is x, 0, and then the y will be 3. Next point is 1. The x is 1, and the y would be 4. And the last one is the x is 2 and the y would be 6. 1, 2, 3. In vertical translation, when the constant is greater than the next graph would be 2 points higher than the original graph. As we can see, this is the original graph, and this is the 2 points higher.
Now I'm going to present about vertical stretching.
Let our first example be 2 times 2 raised to x. The value, as you can see, here are the values of x and y. And now let's proceed to plotting the values of x and 2 times 2 raised to x. So first 0 and 2. Second 1 and 4. And lastly 2 and 8. And now let's proceed to vertical shrinking. Let our first example be 1/2 times 2 raised to x. So as you can see, I've already plotted the points of x and y. And then to solve for the value of 2 times 1/2 raised to x, you have to substitute the value of x with the values of 0. So first, the value of x is 0. Second, the value of 2 times 1/2 raised to x is 0.5.
Now let's proceed to horizontal translation, wherein the equation would be f of x is equal to b raised to x plus c. The constant would be on the exponent. Let our first example be 2 raised to x plus 2, wherein I use the same values of x as I did on the first part. Now as you can see, I have already substituted x with the first value, which is 0. Now let's solve for the value. 2 raised to 0 plus 2 would be 2 raised to 2. 2 raised to 2 would be equal to 4. That will be the first value for x plus 2. And now let's proceed to horizontal stretching. Horizontal stretching has the equation b raised to x times c. Let c be the constant. First example is 2 raised to x times 2. So our x values are 0, 1, and 2. And then as shown in the first few topics, we all know how to solve for the value of y and the value of 2 raised to x times 2. So now let's proceed to plotting the points. Let's first plot the values of x and y. Let this be the original plot. So first is 0, the y is 1. Next is 1, the y is 2. And last is 2, the value of y is 4. And now let's plot the value of x and the value of 2 raised to x times 2. X is 0, value of 2 raised to x times 2 is 1. 4 pala. The value of x is 0, and the value of 2 raised to x times 2 is 1. Next, 1 and 4. And last, 2 and 16.
And now for the horizontal shrinking. Let our first example be 2 raised to x times 1/2. So the values of x and y I have already plotted. Now let's proceed to the values of x and 2 raised to x times 1/2. First 0 and 1. Next 1 and 1.41. And last 2 and 2.
Good day to everyone. My name is Rafael Jericho Iabut, and I'm the one who is assigned to discuss about evaluating logarithmic functions.
And I'm Rafael Resurrection, here to discuss about graphing logarithmic functions.
Tumingin sa aking mata, magtapat na.
Good day.
Down here, simple equation of log base 4 of 16 is equal to x. And in order for us to find the value of x, we need to transform this equation first into an exponential equation. This is a sample of our exponential equation. And in order for us to find the value of x, we need to make the bases the same. And the common base will be 4. After making the bases the same, we need to, or we can disregard the value of the bases already and bring down the values of our exponents. And that will be 1x is equals to 2. And then we need to isolate x, so divide both sides by 1. Cancel. Therefore, it will result to x is equals to 2.
So that you know how to evaluate a logarithmic function, now we're going to talk about graphing logarithmic function, okay? So, all you have to do is have a given 3 raised to x is equals to y. So all we need to do is find its logarithmic function. All you need to do is change the y and the x into y. So it will be 3 raised to y is equals to x, or a log base 3 of x is equals to y. That's it. So all we need to do is graph it. So what to do first? We're gonna make a t-chart. This is a t-chart of the exponential function 3 raised to x is equals to y. So all we need to do is find the domain. The domain can be anything. So I choose 0, 1, and 2. So now we're going to find the y. All we need to do is substitute the x into the given. So 3 raised to 0 is equals to 1. 3 raised to 1 is 3. 3 raised to 2 is 9. Now you got your range. Now you got the t-chart. Now all you need to do to graph a logarithmic function is to swap x and y to y into x. So 0, 1, 2 will be on the range, and the 1, 3, 9 will be at the graphing, at the x, sorry. So all we need to do is make a Cartesian plane. Okay, now so we're going to graph logarithmic function into the Cartesian plane. So I'm going to use a red marker for the exponential and a blue marker for the logarithmic function. So we're going to graph the points. So domain 0 is to 1, x is 0, and the y is 1 right here. 1 is to 3, range is 1, domain is 1, range is 3. 2 is to 9, the domain is 2, the range is 9 right here. So that is the exponential function. Next, the logarithmic function. Domain is 1, the range is 0 right here. The domain is 3, range 1 right here. Domain now is 9 and the range is 2. It's right here. So there you have it. Now that's how you graph a logarithmic function.